Well, hello everyone. Today we're going to talk about the implementation of Huffman code, and the code is already available in the Canvas page. If you go to the module of Huffman code, you will see a list of files that are posted there. Now, what I did, I basically downloaded those files, and here they are. I have them here listed. Let's start building a project, and I'm going to show you how do you run it, and then after that I'm going to go to all the methods inside this project and try to explain how do they work. So let's just go step by step. The first thing I'm going to do, I am going to create a project, and I'm going to call it Test Huffman Tree. So let's go here to the Visual Studio, create a new project, empty. Let's call it Test Huffman Tree, and let's go with that. Just have to wait a little bit, and then after that you go to the header file folder, and you pick all the header files that you have here, which basically I do have 4 of them. And remember, we need to have the binary tree node, and we need to have the Huffman tree, and then we have the priority queue, because all of these header files are going to be included and used. So I'm going to copy them, as simple as that, and I'm going to paste them here. And you can see here that I got 4 of them here. Now after that, you need to get to the implementation file, which is the Huffman tree implementation file. Let's copy it. And you put it in the resource file. Again, this is just me. I like to put in a resource file. You can put it in source file as well. That's not going to be a big difference. Then after that, let's take the test file. Copy that. And you put it here. Right after you're done, let me just open all these files. I'm not going to open all of them. I just care about the Huffman ones. So this is the testing, this is the implementation, and this, where is it? The header. Here's the header. Those are the files that I'm going to be talking about mostly today. Do not build and run. Just go to the build and build the solution for it. Wait for it a little bit, and it should work with no problems. Now I'm done. If you go and click on the Huffman tree here, go to open the folder in the File Explorer, you will find yourself in this folder. Now you need to go to the debug and, no, actually, let's get out. Yep. This is basically where all my folders are located. Inside this test folder, this debug, that's the one that's important. And this is the exe file. This is a very important file. Now what I'm going to do, of course you can navigate through your system to get to this file, but just typing the long path here may take a lot of time. So what I'm going to do, I'm just going to copy it from here, and for simplicity, where's my computer, I'm going to go, for example, inside my C folder here, and I'm going to create C partition, sorry. I'm going to create Huffman folder, and I'm going to put this exe file here. Now what you need to do after that, you need to go to your files, original ones, and you need to copy those text files, because those are going to be the input for this project. So I'm going to copy them and put them here within the same folder. It's very important that you have the exe file here and the text file all inside the same folder. Now that I'm done with all of that, let's go ahead and open the CMD. And then let's change directories, and now I know, change directory dot basically means get out of this folder, and then I get out of the other folder, and now I'm inside the C itself, so by typing dir, I can see the directory structure of the files. Now all I have to do is to change directory to Huffman, so CD H uppercase, and then just press tab. It will continue it for you. Now that I'm in the folder, type dir, and here we go. Those are the files that I have here. As you can see here, I got 3 text files and I got the exe files. Now, I'm just going to go show you how it works, and this is not going to work. It's going to basically stop in the middle and not continue the process. But I'm just going to go ahead and type test huffmantree.exe. I can take the exe if I want to, but let's just keep it that way. And look what's going to happen. Of course, my antivirus thing will jump. It's basically telling you that you cannot run this command by itself. You need to have 3 arguments next to it to be able to run it. The first argument is the weights, the second argument is the code file, and the third one is the text file. Basically what he means, the project has been built based on those three files. So it's very important for you to have them listed when you type and you try to run the code. So I'm going to go ahead and go back here, Huffman test Huffman tree, and now we need to start. The first one is the weight file. Now what you need to do, you need to go to the folder and look, where is the weight file? Well, the weight file, here it is, letter or frequency. So if you double click on it, you will see that every single character with the frequency. As you can see here, space has a lot of frequencies, E has less, and that's basically the file. Now I'm going to explain how does it work, but we'll just keep going now. So all you have to do, come here, type LE and put a space, tap, and it's going to continue for it. That will be my first letter, first file. The second file is code file. Now the code file contains a message to be decoded. So the message already has been coded, which basically means it's a sequence of zeros and ones, and you want to decode it so you can see what is the message behind it. Now let's go ahead and open the folder again, and I believe he meant this one. You can see this is zeros and ones. You need to decode it. You need to convert it to the actual string. So let's go ahead and put message here. And then finally we have the Go Eagles file. Now after I'm going to run it, and before I press anything, let me just show you the files again. So the first one contains those letters. The second one contains this decoded message that you want to encode it to put it back as a form of a string. And the fourth one is basically you're going to use the same Huffman tree to convert this Go Eagles, and convert it to a sequence of zeros and ones. So let's go ahead and give this a try. I'm going to run it, and here we go. So let's look here. This basically, do you see here this part that I'm going to highlight? This is basically your Huffman code tree. It's not the tree, it's basically the Huffman code. Every single character and its digital binary representation. If you look here, the space has 3 digits and the E has 3 digits. And if you go and compare it to the frequency, you'll notice that those 2 letters are with the most frequencies. And as the frequency goes down, you will notice that the length of those files or sort of characters goes up. And look at the Z here, for example. It's still a very long one. Now, after that, immediately, this here is basically the text file with the zeros and ones that we entered that we need to decode. And what happened in the program, and I'm going to explain that in a sec, right after you receive it and you decode it, you're basically going to have to encode it again, and then the program is going to compare it with the original file, that the original sequence of zeros and ones that was inside the text file. If they find a match, it's going to pass. Otherwise, it's going to tell failed. And after that, you read the Go Eagle message from the file and you convert it into a binary using the Huffman code. And then after that, you took the same binary that you produced and you converted back to a string. And then you compare the string that you created out of this code with the string that's stored in the file and see if they get the same result. And as you can see here, you got a pass. Now, with that being said, I am I'm going to put this down. I'm not going to close it. I'm going to go through the Huffman tree header file, and then after that I'm going to go to the implementation. I'm going to try to explain it a little bit with more detail. So let's look here at the beginning for the test file. The first part here basically is just to make sure that you're going to enter the right 3 files. And then you got argument 1, argument 2, argument 3, just to make sure that you got them all correct. And then for each one of those arguments that you're going to enter, basically you got an IF stream, which basically means you're going to read it from a file. So you're going to read a message from a file, you're going to read another message from a file, and you're going to read the data from a file. The first one, data, is going to represent the frequencies. The message here represents the sequence of zeros that you try to convert it to a binary. And the message 2 is basically going to read the text file and try to convert it to or encode it actually. Now, the first part here is basically you're going to create a vector of a Huffman data. Now, what is a Huffman data? Well, here's a Huffman data. Huffman data is basically a structure that contains two basically elements. The first one is the weight, and the second one is the simple. That's basically what it is. Excuse me. The character here. We're gonna have character. We're gonna have the weight for the character, and we have the constructor here for each one of them. A very simple implementation. So that's basically what would be the simple. So I'm gonna read the files. Just pay attention to this. This is the data that I'm reading, the file with the frequencies. This is the first element in that file, and this is the second element of the file. Wait a minute, I messed up something here. And basically what I'm saying here is, if I go open this file, this is going to be assigned to, where is it, S, and this here is going to be assigned to the weight. Now the question is, why did I clear this as an S while I created it here, where is it, in the tree, as a simple character? Well, because the space is a very, very special case here. It's not a single character. I didn't use a space as a space character. I actually called it a space. So what's going to happen basically here, let's go back to, where is it, the testing. Okay, I'm just going to check if S actually doesn't equal a space. Then basically just use the first character, which is basically, if it's not a space, then it's actually one character. So you're going to go take that character, and when you extract one character from a string, that basically it's a character. Now, what if it's a space? Well, replace it with the actual space. So this is basically just a very, very special case for the space character. So by the end of this part, I'm basically reading all the data. I'm reading all the data from the frequency files, and I put them inside a vector. Right after that, I'm creating a new Huffman tree, and I'm going to, what am I doing here? And then I'm going to build the Huffman tree. Basically, I'm going to talk about these methods later using the simple vectors. And then after I'm building it, I'm going to show the code, and that basically will finish the first part of the code of the implementation, which is basically this part that I'm going to highlight. Right after I'm done with that, I'm going to go ahead and read the message, the zeros and ones message from the file. Right after that, I'm going to decode it using what? The Huffman tree. And then I'm going to show the message that's going to be returned. And then after that, what I'm going to do, I'm going to reverse. I'm going to read. I'm going to build a code. And this build code, basically, I am going to use the decoded message and try to convert the message back to be zeros and ones. So I got the decoded message and I got encoded message. So the decoded message basically is the result of me reading those zeros and ones from the file. And then I'm taking these zeros and ones and I'm converting back to zeros and ones again. And then I'm going to convert the original message that I got with the message that I got from here. If they match, they match. If they don't match, I will get a fail. Right after I'm done with that, I'm going to do the same thing with the second message. What I'm going to do, basically, I'm going to read the message that contains a space, very important, so that's why I'm using getLine, from the file, which is Go Eagles. And right after that, I am going to encode it. I'm going to see what will be the zeros and ones for that, and then I'm going to take the zeros and ones, and then after that, I am going to go ahead and convert it back to a string, and then compare the string that I got from the file with the string that I got from,
Hi, Papa.
Oh, hey, that's my son, he just woke up. Right after I'm done with that, I compare them, and then I got everything done. Now, I'm going to take a break, go make him some breakfast, and I'm going to come back, and I'm going to explain all these methods and the implementation inside this CPP file. So well, here we go again. So this is the implementation file for the methods. I'm going to go through them, as I said before, method by method, and I'm going to try to roughly explain it very, very fast. And then if you want to understand it really well, you just have to go through the details on tracing and all these kind of details. But again, I don't believe you have to go through all of that. So let's just get this started. The first method we have is the build tree. And the build tree, basically, we are trying to build a priority queue. And this priority queue is going to be called the queue. And this priority queue, basically, this is the data type. It's a binary tree. You're going to apply it to using this vector. And this is the compare operation that I was talking about before. Here, the weight of the left tree is going to be greater. If it's going to be greater than the right tree, it's going to return true. I'm not sure why we need that, but again, yes, remember the prior to Q. I just realized, remember that. Just remember again, whenever you remove an element from a prior to Q or insert an element from a prior to Q, you need to compare the left child with the right child to figure out which one of them need to replace the root. So that's why we have the compare function here. So bottom line, I'm trying to create a prior to Q here. Now what I'm going to do here, basically, as you can see here, I got a vector with the Huffman data we call the simples, which basically we have the weights and we have the character itself. So I'm going to go through the size of that vector. Now, what am I doing here? Here it is. I am pushing a binary tree of the first element into that queue. So, as you can see here, I'm pushing the elements inside the queue, but again, remember, I'm not done building the tree. This is the first step. We just push the elements from the vector here into this queue. Right after I'm done with that, I have this while loop here. This while loop says, as long as the queue size is greater than 1, that basically means we're going to keep going until it's actually 1. When you get to 1, that's your binary tree, the Huffman binary tree. So what I'm going to do here, basically, I'm going to create a binary tree. I'm going to call left. And then I'm going to have, what I'm going to do here, look at this, I'm going to top the queue, removing the first element, and then storing the first element, and then removing it. And then I'm taking the second smallest element, and then I'm removing it. And look at this, I'm getting the weights for the left and the weights for the right. I'm adding them together, and I'm creating a new Huffman code. And this is basically the two weights together, and the character here is what? Is 0. That's the simple here. Basically, there's no character. And after that, I'm creating a new binary tree that will basically contain the sum, which is this one, and this is the right, and this is the left. And then after that, I push the new element that I created here, which is the new tree, back into the queue. And I'm going to keep going, keep going, keep going, keep going. As you can see with this while loop, every time I'm taking 2 elements from the queue and I'm adding 1. 2 elements and I'm adding 1. 2 elements and I'm adding 1. You're going to keep going in that process until you get only 1 element. Right after you get that 1 element, you're basically going to have your Huffman tree to equal that element, which basically the last element remained inside that queue. And then after that, you can remove it from the queue. So I'm done with the queue. So by the time I'm done with this method build a tree, this is what I'm getting, the Huffman tree. Now we have the function that follows that is the print code. Now, what am I going to print the code? Basically, what I'm trying to do here, I'm trying to figure out, printing actually, not figuring out. I'm trying to print every single character and the code for that character, the binary presentation for that character, using this Huffman tree that I had here. So I'm going to call this print method. I'm going to pass the outstream object, which basically nothing. The stream code basically is going to be going to be passed as an empty string at the beginning, and this is the tree itself. And I'm going to try to do this. Look at this, very important. As I'm reading the nodes from the binary tree, so I'm getting the data of it, and remember the data by itself, it's a simple and it's the frequency of it. That's what's stored here. I'm checking the simple. If the simple basically equals 0, if it doesn't equal 0, sorry, that's the simple. What I'm going to check if that simple is actually a space character. Then you type space and follow that with the code. If it's not the space, then just what is that symbol, what is that character, and follow with the colon, and then follow with the code. Now remember, the code at the beginning is empty string. Recursively, we're going to start build that code, and look at here. This is the part where, what if actually it does equal 0? If the simple doesn't equal 0, it's going to show it to me. So if this condition is not true, we're going to hit here. This is the very important part. Recursively, look, I'm calling the function. I'm passing out, that's the object stream, and look at this code plus 0 and their code plus 1. When you call this function here, code plus 0, you're basically going to go to the left. And when you call this code plus 1, you're going to go to the right. So recursively, this function here will end up showing you the every single character and how is it represented in that binary tree. So every time you call this function here, you basically, whatever the code that you had before, you're going to add 0 to it. And then every time you're going to call this function, whatever the code that you have is going to add 1 to it. And that's basically how I showed you in the previous video how that code is built. Now I got those binary tree built and I got the code printed, which basically this printing is just the purpose for you to see how it works. Now we're going to go and talk about decode and encode. Now decode, as I said before, it's basically when you have your message in binary, ones and zeros, and you want to see what is the character, the real character using the binary tree. So look at this. I'm going to create a string at the beginning. The string is empty. There's nothing there. And I'm going to create a binary tree. I'm going to call it the current tree, which I'm going to basically assign the Huffman tree to it. And I am going to go through the length message. So this is basically the sequence of zeros and ones. And what I'm going to do, I'm going to go through each one of those zeros and ones one by one. And then if that character equal 1, that basically means I need to go to the right. So the current tree is going to be moving to the right. If that character doesn't equal 0, doesn't equal 1, that's basically 0, you go to the left. What if it's not 1 and 0? Let's see here. After I'm done moving right and left, I have to go and check if it's a leaf or not. Now remember, this is all part of the for loop here for each character. So if it was a leaf, this is what I'm going to do. I'm going to get that character, and I'm going to add it to the results. So basically I'm getting the data, which basically the data here represent the weight and the character. I don't care about the weight, I just care about the character, the simple here. So I'm going to add that character, the simple character, to the results. That's basically when you get to the leaf. And remember here, just remember, this is basically going to be, you go left, you go right, you go left, you go left, you go left to right. You keep going, moving between the left and right until you get to the character you're looking for. Right after you're done, you get to the leaf. Right after you get to the leaf, you're basically going to extract the simple, and you're going to add the simple to the results. And after that, before you keep going with the second iteration for this for loop, you basically going to have to set the current tree back to the Huffman tree so you can start all over from the root of that tree. And that's basically how you're going to convert your strings of zeros and ones into a character. Now, the opposite is, how do you encode? What do we have? We have a character here. And for the character, before I do the encoding, I just need to go and show you the build for the code. This is the one that we have to think about. Now, before we do that, let's start here, fresh. The encode function. Let's look here. What do we have? We're going to pass a message. The message basically going to be a pure string file, for example, a name. And then after that, we are going to have to convert it into a sequence of zeros and ones. Now, the question here is, what if I have an array of strings and every single element in that array represent a character, and the index represent the character, and the value itself represent the string presentation of that character, the ones and the zeros. So how is that possible? Well, if you go back here to the header file for the Huffman tree and you go all the way to the end, we have a special vector here. It's called codes, and the codes basically is a type of string. So this codes basically is going to build the array of the elements of the Huffman tree. So this is the first part. You see this codes here. I want to show you something else that is very important. It's the build the code. Here it is. This is build code, and this is build code. Now, when you call the build code at the beginning, you're basically going to clear it up. You're going to set the size, and remember, we're talking about codes here, which is a vector of a type string. And then after that, you're going to call the function where you're going to pass the Huffman tree and the code that's going to be a 0. This build function. Now, this is the build code function where basically you're going to actually build the code. So we need to get that figured out first. So let's go ahead, before we keep going with the encode, let's go into build code. And here we go. This is a little bit critical, and we need to understand what's going on. First of all, we're going to check if the tree is a leaf or not. If it's a leaf, then I want you to get the data, and remember the data basically contain the simple and the frequency. I don't care about the frequencies, as I said before. I care about the simple itself. So I'm going to convert it to a lowercase. If it's a lowercase, just convert it to a lowercase. After that, I'm going to check if that character is a space. If it's a space, then basically the codes of 0, I'm going to assign the first element in that codes array to a space, and I'm going to pass code. Now remember, code at the beginning is empty. Let's go back here. Here it is. This is code. It's empty. Since it's empty, so I'm going to assign it to this one. Now remember, this is going to recursively build. And then if it's not, basically, if the character was, look at this is very important, if the character is between A and Z, then all I'm going to do, I'm going to say C minus A plus 1 equal code. What I'm doing here in this part, I'm basically using the value of the character as an indicator, the decimal value of the character as an indicator of the index. So let me give you this example. What if, remember, the first element with the index 0 is for a space. What if C here that I'm reading here was A? Well, basically, A minus A is 0 plus 1, so it's 1. So it's going to be the second element. What if C was B? Well, B minus A is 1 plus 1, so that's going to be 2. So that's the third element in that array. But remember here, recursively, just remember, we're going to do this recursively, so the code at the beginning equals nothing. This is where you're going to start building the code in this part. What I'm going to do, I'm going to create a new string. I'm going to pass the code, which is basically at the beginning empty, and this is what I'm going to do. This is how I build it. You always put 0, adding to the code, and then you call build code, and you go to the left. So recursively, as I said before, for each character in that tree, you can add 0 to the string, and then you pass it as a part of the code here, and then you go to and you apply the same concept again to the left tree. And then for the right tree, basically, instead of adding 0, you're going to add 1, and then you call the right subtree, and then you go to the right. You go to the right, and you use the right code. And you just keep going here. As you can see here, this is going to be the left code, this is going to be the right code. You're always going to adding zeros, ones, and zeros as you traverse through the tree. By the time you're done and you get to a point where you actually have a leaf, the code was built at that point, and it's going to be assigned depending on what is the character data you just read from that tree. So this is basically how we build the tree. Now, encoding is basically going to make it a lot easier. As you can see, it's very short. You're going to read each character, and then you're going to take the character itself. If it's a space, then you go to the first element. Otherwise, you try to figure out where's the index of that character inside that code, and you print it and add it to the result. And this basically will be the end of the implementation. Now, I'll tell you, from the beginning, when you look at all this code, it's really complicated, but here, try to break it down piece by piece, and it should not be that complicated. Let me just go ahead and run it for you, and we'll see what to do after that. So I'm going to go CMD again. Let's get out of here. Let's dire this again. I don't remember where did I put it. I put it in Huffman, so change directory Huffman. Let's see here, dire. So let's go ahead and try to run it again. Test. And we said, first of all, we put the letter frequencies. Then after that, we put the message. And after that, we put the Go Eagles. And here we go. Now, of course, if you want to test it for yourself, remember the letter frequencies, you're just going to have to stick with this or create your own if you want to, which is very easy if you want to think about that. And then the code, the message, again, you can build one by yourself. And then for the test, just type any text and you can test it that way. So this will be the end of this file. I'm going to post it in a sec. And just remember, if you have any questions, don't forget, just send them to me, and I'll be more than happy to answer them. Before I go, let me just explain something to you. I, again, am not going to ask you to write this code or implement a full Huffman tree implementation, but probably I will just give you, for example, the frequency tables, and I'm going to ask you to draw the binary tree, the Huffman tree. Or I might just give you a code, a table of the code, and I give you a message in zeros and ones, and I ask you to encode it for me. So those are the types of questions, but I'm not going to be able to actually ask you to get the whole thing done in the exam, so you don't have to worry about that. But again, it's important to understand the concept and how does it work, and this is basically, I'm going to tell you, this is my favorite topic in the data structure course. So I am going to stop at this point, and I will pause this video, and remember, if you have any questions, just let me know. Well, have a good rest of the day then. Bye.